Hi everyone. So in the previous video, we looked at confidence intervals for large and small samples, and we found the interval in which the true population parameter lies. But we can also use confidence intervals when dealing with proportions. Now, if you guys like these videos, don't forget to give me a thumbs up, and as always, please do subscribe. Alright, so to explain proportions, we start off with a single sample proportion, and we can do this through an example. So let's say we have an organization and they sample 484, they handpick 484 customers. And from these 484 customers, they find that 257 people like their product. We can then use a confidence interval. So for example, a 90% confidence interval to estimate the proportion of customers that like their product. Now, this proportion is for the sample of 484 customers and not for the entire population. Now, the equation we would be using to do this is this equation where p hat represents the number of customers or the proportion of customers that like the product, and q hat would be the proportion of customers that dislike the product. So in calculating the proportion of customers that like the product, p hat, the equation you can use is x over n, where x is the number of successes or the number of customers that like the product, and n would be the sample size. So in essence, what we're saying is 257 customers out of 484 like the product, and that proportion would be something like 0.531. We can then calculate q hat, which is the proportion of customers that dislike the product, by simply finding 1 minus p hat, which is 1 minus 0.531, and that would give me 0.469. So we can calculate the number of customers that like the product by multiplying the sample size with the proportion. So that would be 484 into 0.531, and I would get 257 as stated in the question, and the number of customers that dislike the product from this sample, which would be 484 into 0.469, which would be 227. And if we add the two numbers together, we should come back to the original sample size, which is 484. Right, so now let's look at the confidence interval. And for that, we will be using this equation. So the first thing we would need is z alpha over 2, which can be found from the z statistics table for a 90% confidence interval. And this value would be approximately 1.645. We then need p hat and q hat, both of which we've already calculated, p hat and q hat, and we would need n, which is the sample size, which is 484. So to calculate the confidence interval, we can use this equation, and it would be p hat, which is 0.531, plus minus z alpha over 2, which is 1.645, into the square root of p hat times q hat, so 0.531 into 0.469, divided by the sample size n, which is 484. And in calculating this, you would get an upper and lower bound for the confidence interval. The lower bound would be something like 0.494, and the upper bound should be something close to 0.568. So this confidence interval gives us the interval with a 90% level of confidence, in which the true proportion of customers that like the product lie for the sample of 484 customers. So this is specifically for the sample, it's a single sample proportion. We can then use this to answer the second question, which is part B. So part B is, can we infer whether the majority of the customers like the product or not? And the answer to that would be no, because the lower bound of the confidence interval is less than 0.5, it's less than 50%. So there is a chance, there is a probability that the true proportion of customers that like the product can be slightly less than 50%. So we cannot infer or we cannot conclude that majority of the customers like the product because the lower bound is less than 50%. Right, we can now extend the single sample proportion for the entire population. So in the previous example, we looked at the proportions for a single sample, but now we can extend that or adjust that for an estimate of the true proportion for the entire population as well. So let's just say we have an organization and out of all their products, they just sample 200 products. So this is the sample. And from these 200 products, they find that 3 are defective. So using this and the confidence interval, you can calculate the single sample proportion as similarly what we did in the previous example. But now we want to adjust that for the entire population and consider all the products. And we will do this using a 95% confidence interval. So the equation we would be using is this. P hat is now x plus 2 over n plus 4. Again, x is the number of successes and n would be the sample size. And p hat of course is the proportion. So let's go ahead and calculate this proportion. X over 2 over n plus 4, x would be 3 plus 2. So 3 being the number of defective products, and n plus 2 would be 200, which is the sample size, plus 4, and this would give me 0.025, which is the proportion adjusted for the population for the number of defective products. So that means you take the entire population, it's quite likely that 0.025% of the products would be defective. We can then use this in our confidence interval, which would be this equation over here. So p hat, which would be 0.025 plus minus z alpha over 2. So for, again, you can go and have a look at your z statistics table. Z alpha over 2 for a 95% confidence interval should be approximately 1.96. So plus minus 1.96 into the square root of 0.25, so 0.025 into 1 minus 0.025 divided by n plus 4, which is 200 plus 4. So if you guys haven't noticed it, this part 1 minus 0.025 is actually Q, which is the the proportion of products which are not defective. So it's sort of like the same equation, except now you adjusted it for the entire population. And doing this, you would get again a lower bound and upper bound for the confidence interval. You should get something like 0.004 for the lower bound and 0.046 for the upper bound. And this would be your final confidence interval, which means the true proportion of defective products considering the entire product range is probably between 0.004 and 0.046 given a 95% level of confidence. Alright guys, so that's it for this video on proportions using confidence intervals, and in the next video we will have a look at sample sizes considering confidence intervals. So don't forget to leave me a like, and as always, do subscribe. Thanks for watching, and I'll see you all in the next video.